So there's another component of measuring algorithms, which is space complexity. So what are the space complexities of both of these algorithms? So let's see if it can tell us that too, right? So does it really understand what's going on? Does it like actually comprehend? Not so much, but it is able to generate likely sequences of words that kind of make sense in the given context. So space complexity of the sieve is O of X. The reason for that is we actually go ahead and create an entire array, one for each of the numbers, right? So that's why that is O of X. So we create a Boolean array, and the space complexity of the trial division is O of 1, because we're not actually creating any auxiliary structures to help us, right? We're just, the only space that we're creating is to store the output itself. So that's kind of the trade-off that we've got going here. The sieve does have some space involved, but it runs much faster, whereas the trial division one has no extra space, though it does have a much worse runtime as we get to higher, bigger sized outputs or inputs. So yeah, this is pretty interesting that it's able to come up with all of this for us and even sort of tell us how they perform in terms of space and time. So if we actually go over to this very popular website called LeetCode, we can actually try to see if ChatGPT can solve one of these questions. So let's actually bring this over here, and we can see, let me zoom in on this for you. So this happens to be the daily question of the day. So LeetCode is a very popular website that's used for software engineers preparing for their interviews. And basically, they're going to ask you this sort of, not really brain teaser, but like sometimes they're brain teasers, but they're basically just questions that basically ask you to implement a solution to in code of your, or in the language of your choice, right? So this question right here is called single element in a sorted array. You're given a sorted array, so basically a sequence of elements, and it's consisting only of integers, so whole numbers, and every element appears exactly twice, except for one element which appears exactly once. And we're going to want to return the single element that appears only once. And our solution must run in O of log n time and O of 1 space. So this, off the top of my head, sounds like a binary search problem due to the fact that it's sorted. So if you're familiar with that at all, that would explain the log n runtime. So basically it's going to be looking like halfway through, checking if it's less than or right, and kind of probing for that, right? So if we go ahead and maybe let's actually see if it can read. Could you solve the problem prescribed in the following link? Here's a solution to the problem single element in a sorted array from LeetCode. So it's right now, it actually went into that link that I sent it, and it's reading out the problem and the examples, and hopefully it's going to give us a correct solution. And the reason why this is going to be pretty cool is because LeetCode actually has a grader. So we're going to be able to test our solution against a suite of tests that will verify its robustness as a solution and see if it also meets this runtime requirement, which is that it must run in O of log n time. So in computer science, you can write all types of code to solve the same problem, but as we saw before, in the case of generating all the primes up to a certain number, it's often the case where one algorithm might be better than another in terms of the space-time trade-off. So if we go ahead and look over here, once again, the code snippet has been annotated by the incorrect language. This is not a SQL script by any stretch, not even syntactically. But if we go ahead and copy that code, we can actually bring that into here. One thing I will note though is that it actually deleted the class declaration for solution, which we actually do need. And it also got rid of something here, which we do need. So if we go ahead and patch that up real quick and we run that, let's see if it actually runs, passes the test cases. And Python is indentation sensitive, so let's go ahead and indent that as well. And sure enough, it accepts, which is pretty awesome. Now, one thing I will warn against is that there's probably some solutions in here that it could have very easily just pulled straight from. However, this is locked behind a paywall, I believe. So yeah, it definitely didn't look there. So we can see that it's accepted. This is only on 2 very small test cases though. So let's go ahead and submit that. That's going to run it against many, many more tests. So if it actually passes this, we'll know it's actually good to go. And that's so cool, right? It actually works. So yeah, and it even gives us an explanation for what's going on here. It gives us the time complexity, it gives us the space complexity. I almost kind of wonder if the reason it did that is because I asked about that for an earlier question, which would be really cool. So yeah, we can see that that actually just works. But what if we wanted it to be in Java? Could you give me Java code instead, right? So that's one thing that could be super cool for sort of applications of ChatGPT is you could have written code in one language and maybe you want it to be in another language because of portability reasons or whatever reason that you may want. And if you ask ChatGPT to like kind of generate the same code for that problem spec in a different language, it's probably able to do that. And let's actually verify if it did it correctly. Once again, it incorrectly annotated the type or the code block here. But as long as you are familiar with coding languages, in fact, let's actually run an experiment on that. I mean, it's referencing this as Java code, but in case you really didn't know, you could probably try copying this code and then asking it what language is this written in. And it should probably say Java because, I mean, that's what it looks like, right? But without further ado, let's just copy that straight into Java, the Java code pen here. And let's submit that. See if it works. Sure enough, it is a correct solution once again. So that's really cool, right? Like you can translate between the two languages here, more or less using the same algorithm here. But yeah, that just really shows the power of ChatGPT in algorithms. And look forward to seeing you in the next video about debugging.